Слово предоставляется, с докладом выступает Эндрю Диксон. И тема очень интересная: спасение хищников в Монголии, модернизация линии электропередач в масштабах страны для уменьшения поражения птиц электрическим током. Предвкушаю большое количество вопросов, но, наверное, давайте будем ограничиться одним, там максимум двумя вопросами по результатам выступления. Остальное мы можем обсудить в перерывах. Please, Andrew.
Good start. I'd like to thank the organizers for inviting me to this conference. My name is Andrew Dixon, and I work for the Mohammed bin Zayed Raptor Conservation Fund, which is based in Abu Dhabi. And I'd like to talk to you today about an initiative of the fund to mitigate dangerous power lines in Mongolia. And this was a project that we implemented with our partners in Mongolia, the Mongolian Bird Conservation Center and the Wildlife Science and Conservation Center. And this implementation was done under an MOU, under the auspices of an MOU with the Ministry of Environment and Tourism for Mongolia. So as Elvira mentioned earlier on, in the Soviet era, most of the distribution lines in Mongolia were wooden, and there wasn't that much of a problem with electrocution. Electrocution was isolated to certain killer poles with lots of strange infrastructure on them. But in the 21st century and the late 20th century, there was a change after the dissolution of the Soviet Union and the economic chaos that followed in Mongolia. A lot of the old wooden power lines were cut down and they need to be replaced. And they were replaced with cheaper, newer alternatives. And the main issue is that a lot of these wooden poles were replaced with steel reinforced concrete poles. So what you see is a concrete post, but inside that concrete post, there's a mesh of steel reinforcement which conducts electricity. And what that does, it allows electricity to pass from the phases of the power line down to the ground. So you get phase to ground electrocution events at concrete poles, which you didn't get to such an extent with wooden poles. These concrete poles have galvanized steel supports, these galvanized cross arms to support the insulators which carry the cables. And for the most dangerous lines, which are the 10 to 15 kilovolt distribution lines, these conductor cables are supported on upright pin insulators. So the major cause of electrocution is the birds touching the cable, either while they're perched on the cross arm or perched on the top of the pole, and they're grounded. It's an electricity, or the electrocution is caused by phase to ground contact. Move forward. So, with the expansion of the electricity network, after the wooden lines were cut down and removed, the power companies improved the extent and reliability of supply for different villages and towns. So the distribution network increased. There was more industrial development in the Mongolian steppe. So power lines started to be erected for mining industries, and tourism developed. And now there are a lot of power lines going to tourist camps. So we see a large growth of this dangerous distribution infrastructure in the Mongolian steppe. And we estimated there are around 30,000 dangerous power poles in Mongolia, but that number is growing all the time. So it's a moving target. And you've probably never seen so many sakers in one place. And this is the number of birds that we picked up just from one power line during our surveys. The problem is massive, and we estimate that about 18,000 raptors were killed in Mongolia every year in the steppe zone through electrocution. And that 18,000 includes about 4,000 saker falcons. A very large number of this endangered species have been electrocuted. For eagles, we find golden eagles and steppe eagles electrocuted as well on these power lines. And we recorded at least 18 different species of raptors electrocuted in Mongolia. So it's a serious problem. There's a large number of birds being killed, and it's a problem which is very widespread. It's right across the country. We started to look at some of the factors that influenced electrocution rates, and electrocution rates weren't the same across every power pole. When we surveyed power poles across Mongolia, we found some power lines killed more birds than others. But what we found was that this was dependent on a number of factors. One is the landscape around the power pole, flat, featureless landscapes. meant that the power poles are really the only perch sites for the birds, so they're very attractive for the birds. But the core thing that was most important was the density of rodent prey around the power line. So where there are lots of rodents, there were much higher electrocution rates. The problem you've got in Mongolia is that the density of rodents is very spatially and temporally variable. So rodents can be in high density in one area in 1 year, the next year, they're not there. They're in some other area. That makes prioritizing the lines or having some sort of triage very difficult, because a line which kills lots of raptors in year 1, when there are no rodents there, doesn't kill many at all. This line that didn't kill any is now killing loads because there are lots of rodents there. So it's difficult to prioritize the lines in the steppe zone of Mongolia because the major factor is these densities of prey. We found that the electrocution rates also varied temporarily over the season, and the highest electrocution rates occurred in late summer, especially during the post-fledging dispersal period. So late July through to September is the main killing season for birds in Mongolia on the power lines. So what we want to do is to try and set up some exemplar studies, something which could be used by other countries as a model to follow, perhaps for mitigating dangerous power lines. And we looked at the steppe zone and thought, well, rodents occur throughout the steppe. They occur in fluctuating numbers throughout the steppe. So we essentially got to fix all the lines in the steppe to be sure that we're going to have a significant impact on reducing electrocution rates. So estimated around 30,000 poles from the electricity maps that we've got from the area. And there are 7 different energy companies which are responsible for these lines across Mongolia. So it was a very large project that we needed to implement. We had to deal with a number of companies and a large number of lines. Before we did that, we looked at different methods of mitigation. What's the most effective way of mitigating these lines? We tested a number of different methods or looked at the efficacy of different methods. So on the left there, you can see the perch deflectors. These were metal brushes that were put on the cross arms, usually shoved in the middle of the cross arm by the power companies. These were not things that we put there. These were already being used by the power companies. And the idea of these is that they're supposed to deflect the bird away from perching on the cross arm. Essentially, what they can do is actually deflect the bird to perching closer to the wire, so they can make the line actually more dangerous. So these were the types of mitigation methods that were most frequently used by the power companies before we started the project. And we found that these were completely ineffective. Another method was to use perch deflectors, but this time to use insulated perch deflectors. So that's just to use an unconnected pin insulator and position that right next to the connected pin insulator. The idea being that the bird has to be further away from the dangerous live pin. And we found that that reduced electrocution rates by about 85% in the trials. So it was a relatively cheap fix, and it had quite a big impact. And early on in the process, that's what we were looking for. We're looking for something that was very cheap, that could be done quickly, because there was no offer of any money to do it. The power companies didn't want to do it. So when you're skint, you try the cheapest option to fix something. Power companies are also using these perch deterrents, which are rotating mirrors. The idea of these is that they stop the birds perching on the cross arm at all. They see this flashing, rotating windmill, and they don't land on the power pole. These actually work very well when they worked, but they're easily broken a lot of them break within a year or two. And once they break, they don't rotate, the birds just perch around there. So their efficacy is quite good, but they don't last very long. So they have very low durability. We also looked at methods of putting insulation on the cables, which is the technique which has been mentioned earlier on for Russia. And we used these cables from covers from Powerline Sentry in America. And I'm pleased to report that they've been on the line for, I don't know, maybe 13 years now. And all but one is still there. So they are very durable. They work very well. They reduced electrocution rates. The black types that are used in Russia failed very quickly in Mongolia. Most of them failed within 6 months. Very few were operative after 3 years. One of the major reasons was because they're used with weak plastic cable ties. Cable ties decay and break, the equipment falls off. So these insulation on the cables worked, but there was an issue with them, is that they present a risk to the cables and they present a risk to the power supply. One issue is that you can get dust buildup on the inside of these covers, and that dust buildup allows a little bit of electricity, a little bit of electrical creep to occur at each point. And when you have a very long distribution line, a little bit of electricity is lost along each pole along that line. And by the time you get to the end of the line, you've lost a significant amount of power because of this insulation covers. This electrical creep can be caused by dust, and it can be caused by ice. Another problem was that with these covers sitting on top of the pin insulators, the wind, when the wind blew, it tended to bend the pin insulators across. And after a while, the pin insulators are at an angle, and it caused the wires to come off the tops of the pins. So there were issues by putting this equipment on the wires, which could disrupt supply. What we didn't want to do was to introduce something across the country which would cause problems for the power line companies. We don't want them to come back and say, oh, look, all this stuff you put on to save birds is costing us money. And so we needed something that we couldn't affect the power supply. So we looked at insulation on the supports, on the cross arms, on the pole itself, and these reduced electrocution rates to the same extent as the insulation on the cables, but they were fail-safe. If our equipment failed, it doesn't have any effect on the power supply. It also means that the power line inspectors, when they go along the lines, they do visual checks. They can see the tops of the pin insulators, whereas when they're covered, they can't do the visual inspections. And then we also looked at methods of using, what would you call it? The suspended insulators. So this would be remediation as opposed to mitigation, because you're changing the structure of the line. Suspended insulators work wonderfully. They reduce the risk of electrocution, but there are logistical constraints with simply changing your power line system from upright pin insulators to suspended insulators. One of the main reasons is because the cable sag. It means the cable is too close to the ground in the middle of the between the two poles, and that causes a danger for passing traffic and so on. So when you have suspended insulators, you generally have poles which are closer together. So you can't simply just substitute suspended insulators for pin insulators for suspended insulators with your current pole spacing distances. So there were logistical constraints why we couldn't do that. Having said that, a few companies did it, so they're not that bothered about the line dropping a few centimeters. But so in the end, we decided on, going with the insulation on the supports. So that was several years of different trial work to look at the sort of covers that were effective. The problem is that there wasn't anything we could buy off the shelf that we could use that suited our requirements. We needed our equipment to be effective, so it had to work, it had to reduce electrocution rates. It needed to be durable, so it shouldn't fall off after 6 months or need replacing after a year or two. It should be on the line for as long as the line stands. It should have no impact on the supply, so the power company can't come back to us and say, you've ruined our power supply. That means it's fail-safe. If our equipment falls off, it's damaged in any way, it doesn't affect the infrastructure. It also needs to be simple and quick to install. You don't have to take things apart to put it on. You just put the stuff on the line. You're not taking anything apart on the line. And it also has to be low cost, because we want to try and do 30,000 poles. So these are quite strict criteria. And when you go to the shopping center and look for all your different mitigation stuff, none of the things that we could find off the shelf met all those criteria. So I had to design something myself and then get that made. So what we designed is a cover to go on the top of the pole. This is a cover made of something like UPVC. It's a hard PVC, which has got a long life, as long life supposedly as the concrete pole itself, and a similar sort of UPVC cover to go on the cross arms. And you can see them in situ there on in our poles. These are the ones once they've been put in place on the power lines. So we started the work in 2019. And I don't know why that slid down there, but we've done 27,000 poles. So 27,000 poles have been mitigated with this mitigation cover across 6 different electricity distribution company regions. We estimate that we've now done about 80% of the dangerous lines in the country, but we keep finding more new lines all the time. So, but most of those most dangerous lines, which killed lots of birds previously, have now been mitigated with this equipment. So this year we went around the power lines. We just did an audit of the lines because the equipment was put on from 2019 through 2020, 21. And the problem then was COVID. So the companies were going out and putting these things on, but we couldn't go and work with them. We couldn't see what they were doing and so on. So we had to take an audit this year to see what was the equipment was on the line, and everything's working, everything's running fine. We compared the electrocution rates found, the electrocution rates at the power poles with the Mohammed bin Zayed Raptor Fund mitigation put on the top of the pole and on the cross arms. And we found that it significantly reduced electrocution rates compared to other poles along the same lines that didn't have the mitigation on. So along the lines, there's some poles which either had mitigation only on the cross arm or only on the top, and some didn't have it on at all, simply because poles had slightly different structures. So the reduction is about 95% reduction in electrocution rates, and there is still quite high electrocution rates on the anchor poles. The anchor poles, we just essentially requested the power companies switched from overhead jumper wires to jumper wires that passed underneath the cross arms. But unfortunately, when we went to check the audit, very few power companies did that. They just skipped the anchor poles and carried on the lines. But what we found is that this form of mitigation, this plastic cover, clip-on cover, and the bolt-on cross-arm covers, very effective, quick and easy to install, and cheap to put on. They're very durable, so the longest they've been on the line is 4 years. We're given, I think it's a 70-year lifespan for the material. It's ASA, it's acrylonitrile styrene acrylates. I think it's called ASA. It's a type of UPVC. But we've got no losses. In fact, the only measurable losses for 1 to 3 years is about 1 in 5,000 cross-arm covers had fallen off, and about 1 in 10,000 pole top covers had fallen off. So they're very durable. They're easy to put on. They can't make mistakes with them, really. So you don't get a lot of poorly fitted equipment because it's simple to fit. The cost of the equipment to mitigate 27,000 poles, the cost is a bit difficult to assess because to make these, we had to make an injection mold for the top covers. So making the injection mold meant carving an aluminium block, which I think was about $16,000 to make the mold itself. Then when the price of plastic went up, we had to switch from a sort of generic double pin insulator top to a single one, which meant we had to make another 2 injection molds because we didn't have symmetrical tops. So there were some expenses that went into the manufacture, which weren't initially considered, but ultimately, when we did the 27,000 poles, the actual cost of manufacturing, that includes making the molds, getting the plastic, and getting the things made, they worked out about $44 US a pole. The transport costs were about $6 per pole. We had increased transport costs because of COVID. We had to switch drivers, switch lorries at the border and so on. And the implementation costs worked out about $15 per pole. And that was paying for engineers, paying for the partners to work and coordinate and so on, and paying for taxes in the country. So the cost is still relatively cheap, especially when you consider Mongolia is trading Seika Falcons. They charge $10,000 US or maybe more for 1 permit to take 1 Seika Falcon. Then 1 Seika Falcon permit can fix a lot of power poles. So the Seika has got a capacity to pay for its own conservation if the Mongolian government would put the money towards something like this. So to summarize, the insulation was easy to install on the existing lines. It's long lasting, it's relatively inexpensive, and it's effective at reducing electrocution risks. It doesn't get rid of them, doesn't eliminate them, but it brings them down to a much lower level. The other thing is that this type of mitigation, it's not actually, you could incorporate it into a new build line. You could, as you build a new line, you could add this equipment to it because it's got the same expected lifespan as the hardware on the line itself. So you can incorporate it into new build lines. And cost is often a major factor in the decision-making process when they're planning new lines. So this is still relatively cheap. And when you add the cost of adding this to a new line, it's a small fraction. It's less than 1% of the cost of putting up a line is to add this equipment to a new line. So in a way, it doesn't have to be only for mitigating existing lines. It could be incorporated into new lines. And the challenge that we have now is trying to use this jargon phrase in mainstreaming the idea of raptor safe power lines into Mongolian stakeholders. That means to get Mongolian stakeholders to really consider the issue of raptor electrocution in everything that they do. So make sure it's at the forefront of their thinking in terms of new lines and how they develop their infrastructure and so on. So ideally, we would have done that during the process of fitting the mitigation. We would sort of leverage the goodwill of putting this equipment on and try to get the power companies to really think about the problem. But COVID really messed that aspect of it up. So there's one of the things that as we move forward with the project now, we're really trying to build on what we've done and to get the power companies to seriously think about putting this mitigation on all the new infrastructure they put into the country, or to use raptor safe infrastructure in the first place. We also need to look at the mitigation of anchor poles, and we estimate there are probably still about 6,000 to 7,000 dangerous poles still in the country. So there's still birds being killed and there's still work to be done. Okay, thank you.